So in this video today, what we're going to be going over is ways to expand logarithmic functions. So the problem gives us b equals the natural log of 3x squared all over y. And for this problem, I'm going to remember that I have logarithmic does not have an a in it, or at least log doesn't. But the log rules state that whenever I have a quotient inside a logarithmic function, that what I'm going to be doing is subtracting them. So I'm going to take the upper function, which in this case is a, then I'm going to be subtracting it by the lower function b. The other ones that we have are the product of two functions inside a log, which then, because we did a quotient here, which is what we're dividing, we're going to be subtracting. For this one here, we're going to be doing a product, so then we're going to be adding the two functions inside the logarithmic. So I'm going to have the natural log of a plus the natural log of b. The other one, which tends to come up a lot, is the natural log of a power. We'll make this x squared, just for terms. And what this tells me is I can take this 2 and pull it out in front here. So then this becomes my 2 natural log of x. So in this problem here, it tells us to expand as much as possible. So what I'm going to look at here is, okay, what looks familiar to me from these laws? So I'm going to notice here that I've got the quotient log law, and I've got a quotient here. So we're going to then apply this law into here. So I'm going to have the natural log of my upper function, 3x squared. Then I'm going to be subtracting it because it's a quotient. And then I'm going to be having the natural log of y. My next step is, again, to look at what makes it very familiar, and I'm going to look at the second one. So I see here I've got a 3 times an x squared. So I'm going to use the second law here and then expand that out. So then I have the natural log of x squared, adding it to the natural log of 3. Then I'm subtracting all that by the natural log of y. The last step is to then look at the...
Hey, Andrew. I have a question.
Yes, Jill, go ahead.
Why can't you put the 2 out in front of the natural log?
That's a great question, Jill. So what Jill's asking is, okay, well, why can't I just then take the natural log of 3x squared? That's a squared term, not a cubed. Well, it wouldn't matter anyway, but for this purpose, it's going to be a squared. She's asking, why can't I just take the 2 out in front and then just have the 3x there? And the reason why we can't do that, Jill, is because the only term that we're squaring is the variable x. So to answer your question, this is not correct. The only way this would be correct is if the problem's asking what is the natural log of 3x quantity squared, then we would get 2 times the natural log of 3x. Good? Okay.
Thank you, Andrew.
You're very welcome. So now after that, what we're going to do is we're going to then use the third law where we bring the 2 out in front of the exponent here. So now we're going to have 2 multiplied by the natural log of x plus the natural log of 3, all subtracted by the natural log of y. And this is our final answer. Now on the answer, in your answer column here, you would notice that you have a box, natural log, another box, plus another box, natural log, another box, and then our last natural log box series. And with this answer, I messed up on this myself when I worked the problem out, is you want to be careful with this term, that what this means here, when it has a negative natural log of y, that also equals a negative 1 times the natural log of y. So when you're plugging in your answers here, I'm going to use a different color so you see the answers versus just the box. I'm going to be plugging in the 2 down there, then my x. I'm going to look here, okay, the same rule applies with just the natural log of 3, so there's a 1 out in front, then I have the 3. Then I'm going to make sure to put in my minus 1 and then my final y term as my answer. Great, thank you guys so much, and I'll see you in the next video.